guys, welcome to Ask Raghulan. Today we're going to see one interesting hot topic that is going around in the science space, which is we have found a planet with a liquid water. So now this is an exoplanet, which is like a planet which is outside of our solar system, but this has not been done before. So this is the very first time that we have found an exoplanet which has got liquid water present in the surface of the planet. So far we have found several of these possible planets or moons which could have water or ice or some sort of a different form of water and things like that, but this is the very first candidate which is like within a very hospitable zone, that is a temperature is ranging from 0 to 40 degrees Celsius, and it also has a potential of having a life form in the planet as well. So let's look into some of the other candidates and the current one as well. So the first one we're going to look into is Mars, which is our closest neighbor planet, and Mars is actually around 63 degrees Celsius temperature, which is because it's getting the sunlight from the sun, so it gets a bit warmer compared to other planets which is in our solar system. And then the distance from Earth is around 225 million kilometers, so that is actually the closest one. So then the way that we have found that there is ice is basically we have got some indication, because we've been imaging Mars for like over a decade now. We got several probes that's been sent over, and so we have seen the coloration of some of the slope lines have been changing from season to season. So that means whenever there is a warmer season, there is a light colored salt deposits have been found on the surfaces in some sort of stream lines, and then after a period of time it gets darker, and then again there is a lighter version of it. So what people predict is there could be bryness. This is actually a highly hydrated salt. We call it as salty water. So this is a different version of that. It's basically a very hydrated version of salt. That means a salt which has got liquid in it, which is water in it. And so one of the things that we are curious about this one is generally salty water doesn't get becomes ice because of the salinity. So more the salinity, it's harder to become harder for the water to become ice. So now since the Mars temperature is around minus 63 degrees Celsius, which is, let's say, even the saltiest water generally becomes ice around minus 43 degrees Celsius. So it's around the right range for it to get saltier, and at the same time when the planet gets warmer during the warmer seasons, it actually starts becoming little bit of water, or maybe a sort of like a vapor which comes out and then it deposits as a new set of salts, and then it evaporates. So that could be the thing that we found so far. So that is with the Mars. And the second candidate is Europa. So this has been in news for a while, and the main sensation of Europa is basically it has got liquid water. People think that it has got liquid water under this very thick ice sheet, and the reason it has been protected for literally millions of years, and they're saying that there could be possible life forms under the ice sheets, and we don't know sure that it's either in primitive life form or a bit more mammalian version of it or more intelligent version of it. But so far what people have seen is it has got some thick ice in it. So the way people find detection of water or ice is basically it actually shines compared to the other planets, which is like say a bit more rockier. So one of the things that the scientists do is they use a technique called spatial reflection or glint. So they call it as a glint. So this is basically when a planet moves around its own sun or nearby star, it reflects. Sometimes when people are watching through a telescope, it reflects some portion of the light, and so that is actually indication that that planet has got either water or ice. Most cases, if it is too far from the nearby sun or the star, generally it will be in form of an ice, but if it is closer, then it will be in the form of water. So that is basically the detection method people are using. There is also other methods, but that is actually the closest one that we use. And So with respect to Europa, it is one of the moons of Jupiter. Jupiter has got 79 moons. So this is one of the moons for Jupiter. And other thing interesting about this one is this is actually the sixth largest moon in the solar system and slightly smaller than the our moon or Earth's moon. And so the advantage of that one is since it's of its massive size, there could be more the geoforce within the planet, which actually helps shift the ice plates and which also helps in generating some friction to produce some heat, and that actually helps to maintain some water within the system. So another thing is like so this might have liquid water, and one of the things people also say that since because of the size of this object, it could have water which is about depth about 100 kilometers down from the top sheet of ice. The top sheet of ice, people predict that it could be between 30 to 70 kilometers of thick ice. So it's actually very, very thick ice, and there could be water of 100 kilometers of depth, pretty much oceans underneath that. And they also say that most of this planet could be covered in water, so we're looking like sort of like a water world. And then the temperature of this one will be ranging between 160 degrees, minus 100 degrees, 60 degrees up onwards. So it gets colder and colder. So that's the sort of temperature. Now this is the sort of temperatures, we start getting more, we go away from the nearby stars until it gets very cold. And when it's get too cold, it's going to be instant evaporation of water, even if it's there, or instant freezing. So that could be the two things that we would see. And then the detection, how we have detected it. Hubble Space Telescope, it's one of the sophisticated ones that we have. We generally use Hubble Space or Kepler. So the Hubble Space Telescope, which was launched several years ago, detected Cairo geysers. So the Cairo is actually a mean ice. If you heard of cryogenics, cryogenics is basically preserving your body in ice, so that in future, if there is a technology to unfreeze it, and then if we can animate the body, probably we can get life back again. So in hopes of it, a lot of people generally tend to freeze their body, and so that is one of the things. So now they're talking about cryo geysers. So the cryo geysers means ice geysers. That means it actually throws a bit of ice. In Earth, we would have seen these sort of things in Iceland and some of the remote places where we see geysers is basically a hot stream of air or combined with water streams out of the earth, and so this is just opposite of that. It's going to be icy waters or probably smoke of ice or something like that, which just comes out of the surface. It's due to some of the pressures which is underneath. So that is what the detection is, and the distance from our planet is actually around 628.3 million kilometers. So that's quite far, and it's unreachable for with the current technology. We wouldn't be able to do much with that. We have sent few probes which has taken some photos while it's go past Jupiter, but we have not sent specific to Jupiter. But there are missions that is going to be specific for it. One of the missions is India's mission in the coming years. One of the mission is actually targeting Jupiter and the moons around Jupiter. So they're going to send a specific probe to get closer to the Europa. And so what people think about how do they have water formations is basically of two scenarios. One is tidal flexing, and another one is friction between the ice masses. So these could be the two scenarios where it actually could produce water. Tidal flexing is basically the regular tidal motion that you see in your seas and oceans and things like that, which actually could the friction between the molecules actually could generate some sort of a heat energy or more movement in the current system in the water, which actually creates a sort of like a high pressure, low pressure, and then sort of more energy getting generated within the ice sheet, which keeps the water in the water form. And then another one is when the ice plates move, just like our tectonic plates in our Earth. They tend to create friction between one another, and these are giant piece of ice, so generally they generate quite a lot of energy, and this could actually produce more water, and pretty much it keeps it in a cycle where they keep having ice as well as liquid water in the system. So that is what we found so far with the Europa. And the next one is Enceladus. Enceladus, this is actually a moon of Saturn. So Saturn is one of the other planets that we have in the solar system, which is a bit far from the Jupiter. So it's going to be colder than Jupiter. So we expect the temperature to be minus 201 degrees Celsius. and then the distance would be around 1.272 billion kilometers. So you're looking at quite a lot of distance compared to the previous detections. And then this one we also seen geysers of water. So this is not geysers of ice. Remember this, the previous one is a geysers of ice from the Europa, and this one is geysers of water. So that would be a bit more positive, because the problem with us is currently we're using telescopes which looks at it with a very far distance. And when some of these planets such as which is away from Jupiter, if you look at it, they are all more cloudier. So Uranus, Neptune, some of these people call it as ice giants, and these planets are pretty much like cloudy planets, so people can't see what's underneath the cloud. So what people come up is basically based on the facial changes that happens on the planet. People think that there could be more movement on the surface of clouds, so that could be because of more vapor that's been generated, or some of those movement due to changes in temperature and things like that. And so people detect geysers of water. So that's pretty much one of the main thing people tend to look for in terms of in a spatial telescope kind of things. The only thing they can see is in the spatial indication of any way that they can say there is water. So that is one of the detections they would find water. And the next one is Charis, and Charis is actually a dwarf planet which drifts between Mars and Jupiter, and it's actually between that belt where you could see a lot of those space stones, which actually creates a sort of like a little belt. So it's one of those dwarf planets which circles around that space, and it has got a temperature on minus 143 degrees Celsius, and the distance will be 444 million kilometers. And so this is actually the next closest one compared to the Mars, because it's between the Mars and the Jupiter. And the next most important thing, which is the news which came in few days ago, is K2-18b planet. It's an exoplanet, so it doesn't reside within the solar system. So this has got water. People have found out that it has got water, and so that's the coolest thing. So what is this K stands for is basically Kepler telescope. So that is the one which picked it up. So if it is Hubble, generally they name it with H and things like that. If it's Kepler, it will be K. So it's K2-18b, and the temperature is around minus 40 degrees Celsius, 0 to minus 40 degrees Celsius. So that is actually a zone where there could be liquid water. So if the water has got salinity, then it will be liquid water rather than being in ice form. So which is, they have found the temperature should be within that range, and then the distance will be around 650 million kilometers. So it's not just million, it's million kilometers. So that is around 111 light years. So that's, let's say a light is traveling, the speed of light is very fast, and the light is traveling at 111 years, and whatever the distance it would reach, the light would reach, is what the location of this planet is, distance of this planet is. So it's actually very far. So with the current technology, we wouldn't be able to do more in-depth study into the planet. What people are waiting for is the next version of the telescope that we plan to send it in 2020, and that would actually even detect gas that is released within the planets. So so far what we're doing is we're just checking the visual changes that is happening in the planet. With the newer version of this telescope, which will be sent in 2020, it should be able to see gases that is released within the planet. So now if there is a living organism, they tend to produce a certain set of gases. So let's say methane or oxygen or carbon dioxide or some of these gases. So these gases have got certain signatures. So this new telescope will be able to pick those signatures. And next one is this planet is within the hospitable zone where it could have liquid water, plus it could also support life form. So people also say that if the conditions are true, there is a chances there is already a life form that exists within this planet. All right, so that is all the updates, guys, and we'll catch up in another video. And thanks for watching. If you like it, subscribe to the channel. Thank you.